Questions 21 through 25 on the 2012 Grade 7 Gauss Math Contest. A triangular prism has a volume of 120 centimeters cubed. Two edges of the triangular faces measure 3 and 4 centimeters, as shown. The height of the prism in centimeters is. The volume of this shape is calculated as follows. The area of the base times the height of the entire shape. Now the volume of the height I can label right here h. Now the area of the base is right here. This is the base, right? That's the base, and that's also a base. Either one, same dimensions, 3 by 4. So this is 3, and that's 4, and that's 4, right? No problem. So the area of the base is just a triangle. So it's 1/2 base times height, and you can use either one, 3 for the base, and height you can use 4. And then I have to multiply all this by h. The volume they have given me is 120. So there you go. That's the equation. Solving for this, I get 240 is equal to 12h, and therefore h is equal to 240 over 12, and that means h is equal to 20. So number 21, the answer is B. A quiz has 3 questions, with each question worth 1 mark. If 20% of the students got 0 questions correct, 5% got 1 question correct, 40% got 2 questions correct, and 35% got all 3 questions correct, then the overall class mean average was. So let's just say there's 100 students, right? Makes it easier for us. 20% is 20 students, and 20% of the class got 0 correct. And then we've got 5%, so 5 students got 1 correct, 40 students got 2 correct, and 35 students got 3 correct. So now we have to figure out the average. So it would be 20 times 0, plus 5 times 1, plus 40 times 2, plus 35 times 3, and then of course we have to divide by the total number of students, which is 100. So this becomes 0 plus 5 plus 80 plus 105, all divided by 100. And that is 190. Yeah, 190 divided by 100, and therefore that is 1.9. That's the average. So number 22, the answer is B. The number n is the product of all positive odd integers from 1 to 99 that do not end in the digit 5. That is, n is equal to 1 times 3 times 9 times 7 times 9 times 11 times 13 times 17 times 19 ... 91, 93, 97, 99. The units digit of n is. Okay, so let's talk about this first. N is 1 times 3 times 7 times 9. And remember, they skip over any number that has a 5 at the end. So as you notice, there's no 5 in here, right? Because if it was all positive odd integers, you'd have 5 in there, but they're not counting the 5s. Okay, you keep going with odd integers, 11, 13, but you skip over 15 because that ends in a 5. So we got 17, 19. And then you just keep doing this, right? Until you get to the very end, which is 91, 93, 97. You skip over 95, and then 99 at the very end. All right, so they want you to figure out the units digit. Units digit is the last digit of a number. So if a number is, for example, is 2, 7, 9, 4, 0, 8, 5, 1, 6, the last digit is the 6, and that is known as the units digit. So that's our task. Now, obviously, you can't multiply this out, even in a calculator, and manually it would take absolutely forever. So you have to have a technique. So here is the technique. When you look at units digits questions, you only have to look at the units digit of the number. So for example, the first 3, the units digits, since these are single digit numbers, their units digits are the same, right? Those are the units digits. But what about the next 4? Just look at the units digits of each of those. So it's again 1, 3, 7, and 9. And you'll see that pattern continues all the way until the very end. The units digits of the last 4 are again 1, 3, 7, 9. And that's it. So all you have to do is just look at the units digit. You don't need the full number. Okay. Now let's do this. Let's look at these. They're all the same. So 1 times 3 times 7 times 9 is a number you can easily do. It's 189. So all of these are 189. Correct? And again, you only have to look at the units digit. What is the units digit of 189? It's 9. So I have to just look at 9. So that makes things much easier for us. So 9 times 9 all the way, to the very end. But my question is, how many of these 9s are there? That's very important. Well, that means we have to go back and look at the original one. And a simple way of thinking about it is that from 0 to 10, I have 4. From 10 to 20, I got another 4. And then so on, right? From 20 to 30, I have another 4, and so on. All the way to the very end, at 90 to 100, I'll have another 4. So every 10, I have 4 of these numbers. So that means I have 40 numbers in total. Correct? Up here. But here, I grouped them. I grouped each group of 4. So since there was 40 numbers, and I grouped them into groups of 4, I have 10 groups of 4. And for each group of 4, I produced a 9. So that means there's 10 of these 9s. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. Right? I hope you understood all that. So I've basically reduced the question to this. The good news is we really don't need to go any further with this question. We're done, because you can easily do this on a calculator. 9 to the power of 10. And that number is 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. What's the units digit? It's 1. Right? So it's a cool little question, and I encourage you to learn these types of questions, in particular the shortcuts. So number 23, the answer is A. PQRS is a parallelogram with area 40. If T and V are the midpoints of sides PS and RS respectively, then the area of PRVT is. PRVT, that is the shape they want you to figure out the area of. Okay. First, let's draw some lines that hopefully will help us. I'm going to extend PS like that. And then what I'm going to do is draw a height from R down to that line, and of course this is a right angle. So that red line is my height for this question, for this diagram. Now, how do you figure out the area of a parallelogram? It's basically base times height, like that. In this particular parallelogram, the full one, this would be my base, and the height I've just drawn right there. Now, I don't think I know any of those values, right? They just give me the area. Okay, let me just plug that in there. 40 is equal to base, which is PS, times height. And so far, that's all I've been given. Not much more than that. Okay, no problem. We'll keep that for later. Now let's go back and look at PRVT. PRVT is what they want me to figure out the region, the area of. Well, PRVT is going to be half of the parallelogram, which is PRS, minus this little guy, this triangle, TSV, I guess. Correct? I hope you're convinced of that. So just to recap, PRVT is this region. How do we get that? Well, we take that big triangle and subtract from it this small guy. And when you do, you'll get PRVT. Okay, So PRS, first of all, which is PRS, is just half of the parallelogram. Parallelogram has an area of 40, so half the parallelogram will be 20. Right? Now we have to concentrate on TSV. TSV is not a parallelogram, it's a triangle. So that will be a different formula. Similar, but different. 1/2 base times height. Okay? Now, the base of this triangle is TS. So put that in there. And the height, well, the height is from here to here. Now, they tell me that V and T are the midpoints. So since V is the midpoint, if you drew a line from V to H, it cuts H in half, meaning this is the same as that. So the height of that, which is from there to there, is essentially going to be half of H. So this height is H over 2. All right? So now we got 20 minus 1/2. TS now, what's TS? Well, TS is half of PS because T is the midpoint. So this becomes PS over 2, and this is H over 2. So this now, combining, we get PS times H all over 8. And then PS times H is 40. So we got 40 over 8. And then therefore this is 20 minus 40 over 8 is 5. And therefore that gives you 15. So number 24, the answer is C. The positive integers are arranged in rows and columns below. Row 1 is 1, row 2, 2, 3, row 3, 4, 5, 6, row 4, 7, 8, 9, 10, row 5, 11, 12, 13, 14, 15, row 6, 16, 17, 18, 19, 20, 21. More rows continue to list the positive integers in order, with each new row containing one more integer than the previous row. How many integers less than 2,000 are there in the column that contains the number 2,000? Well, what we want to do is first get some sort of a general formula, and that will help me understand where does this 2,000 actually show up, what row. Right now I'm not really sure. So what I'm looking at is what is my formula for that largest number, because that immediately comes striking as the sum of the digits. So for example, that last number is obviously the sum, right? Because 1 is equal to just 1, but 3 is equal to 1 plus 2. 6 is equal to 1 plus 2 plus 3. 10 is equal to 1 plus 2 plus 3 plus 4. You see how there's a pattern there? I immediately recognize that pattern. So that means if you have row n, the last number of that row, let's just say it's way out here, is going to be the sum of all the numbers from 1 until n. Okay? So for example, it will be 1 plus 2 plus 3 all the way until n. And it's a grade 7 contest, so I'm not sure if you know this formula, but it's number 25. That's why it makes it difficult, I guess. It's the formula as n times n plus 1 divided by 2. Okay? Anytime you have the sum of consecutive numbers from 1 to n, you can just use that formula. So let's prove that. For row 6, 6 is my n in this case. Well, if I put 6 into this, I get 6 times 7 divided by 2. And that is 21. There you go. What about for 5? When n is 5, I get, using this formula, I get 5 times 6 divided by 2, which is 30 divided by 2, which is 15. There you go. Let's do one more. I'm sure you're convinced, but let's just do one more. When n is 4, using this formula, you get 4 times 5 divided by 2, which is 10. And as you can see. So generally speaking, if the row is the nth row, the very last term in that row will be n times n plus 1 over 2. Okay, so that is very helpful. Now I've got to figure out in what row approximately is this number 2000. I don't know. Well, I'm also not sure where in the row it is. Is it the very last number, or is it the very first number of the row, or is it somewhere in the middle? I don't know. So what I'm going to do is just assume that it's somewhere, it could be the last one. Let's just say, I don't know, but it'll give me at least an approximation. So I'm going to say, maybe it's the last one. It'll give me an approximation of what n is. So if I do this, it's n times n plus 1 is equal to 4,000. And again, it's just an approximation, so what we can do is, this is very similar to n times n, right? So that's like n squared. So just take out your calculator, and calculators are allowed on the Canadian contest. Take the square root of 4,000. And when you do, you get approximately about 63. Okay, that helps me. It may not be 63, but it helps me. At least it's in the vicinity. So let's figure out a possible scenario. Let's say n is 63. If n is 63, then what is my last number? Well, I just use that formula. So I get 63 times 64 divided by 2. And when you do, you get 2016. So that means in the 63rd row, the very last number is 2016. Okay, that's very helpful actually, because that means that the number 2000 is going to be in the 63rd row. How do I know that though? Well, because every row, the row number tells you how many numbers are in it, right? The first row has 1, second row has 2, sixth row has 6. So the 63rd row is going to have 63 numbers in it. And that means that 2000 has got to be in there somewhere. Yeah, dot, 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 I'm not going to list them all. And the very first number, well, it's going to be 2016. You got to be a little bit careful here. 2016 minus 63, but that doesn't give you, you have to add 1. Okay, you got to be a little bit careful. 1954, right? Because 1954 to 2006 inclusive is 63 numbers. Okay, so I just want you to make sure that you don't, make a mistake by one number that could mess up the whole question. And as you can see, the answer choices are very similar because they're anticipating that. Okay, so we got a pretty good result here. You got 1955 and so on, right? Dot, dot, dot. So we know that 2000 is in the 63rd row. Okay, but they want you to figure out what column also. Okay, you say, oh boy. Well, I got the row, but they want me to figure out the column. All right, fine. Well, how do I do that? Well, it shouldn't be that bad. Let's just talk about this. The very first column is this one right here, right? Right there. And in that column, you're going to have the same number as the row, for example. If I asked you how many numbers are in that column, well, you can count them. 1, 2, 3, 4, 5, 6. But the good news is, all you have to do is just look at the row number. It'll be 6. So if I asked you how many numbers are in the first column all the way down to this guy, the answer is going to be 63. So there's 63 numbers in this column. Now, if I asked you how many numbers are in the next column, just in this first 6 rows, well, you can count them, 1, 2, 3, 4, 5, but as you can clearly see, it's 1 less. So same thing, if I asked you how many numbers are in this column, it's 1 less than the 63, so it's 62. Does that make sense? I hope so. So if I asked you how many numbers are in the column that contains the 2000, well, we have to first figure out where is the 2000 in terms of its placement. Well, this is obviously the first term. This is the second term. 2000, if you keep counting like that, it'll be the 47th term. Right? You can count it. It's pretty straightforward. Or what you can do is you can just take 2000 and subtract from it 1953. Okay, you can do that as well. 2000 minus 1953. Not 1954, 1953. And if you do that, you also get 47. It's the 47th term in that row. So, same logic. The first column contained 63 numbers. The second column contained 62 numbers. The third column would contain 61 numbers. So the 47th column, you just have to keep subtracting. Or you can have a little bit of a trick. Let's say this number is x, right? Notice this number and this number add up to 64. This number and this number add up to 64. So that means this number and this number have to add up to 64. And that's a little bit of a trick. And therefore that number must be 17. Okay? Now, just when you think you're done with the question, there's one final trick. Please do not circle 17. You say, well, why? Isn't that the right answer? No. Read the question carefully. How many integers less than 2,000? So they don't want you to include that 2,000. They want you to include all the column above it. See what I mean? There's 17 numbers in that column if you included the 2,000, but they want you to count only the numbers less than 2,000. So, take out that 2,000, that leaves you with 16 numbers. It's a great question, number 25. The answer is D.